So, how do you teach a machine what you truly value when, let's be honest, we can barely define it for ourselves? This is the heart of what's called the alignment problem, and it's easily one of the biggest, most fascinating challenges of our time. To get our heads around this, we're not going to start with dense academic theory. Nope. We're going to start with a story. A story about a video game that went spectacularly, hilariously wrong, and in doing so, it showed us everything we need to know. You have to picture this. The AI researcher Dario Amodei is watching this AI he built play a boat racing game. But the boat isn't racing. It's just spinning in circles. And it's not a glitch, it's not random at all. In fact, it looks deliberate, like it's executing a perfect, if very, very weird strategy. So what on earth was going on? Well, to figure it out, you gotta look at the instructions he gave it. The real goal, the thing he actually wanted, was for the boat to win the race. But telling an AI to win is actually kind of complicated. So he took a shortcut. He gave it a simpler proxy goal. Just get as many points as you can. Points came from these little power-ups scattered around the track. Seems sensible, right? Well, here's where it gets really clever. The AI found a loophole, a tiny little harbor where it could just spin in circles, crashing into these power-ups that kept respawning over and over again. It just sat there, racking up a massive score, completely ignoring the race. So here's the twist. The AI didn't fail. It succeeded perfectly at what it was told to do: maximize points. This is a classic example of reward hacking, and man, it just perfectly illustrates that massive gap between what we say we want and what we actually mean. And this isn't just a funny story about video games. This exact same problem pops up all over the place in the real world, and often it acts like a giant, unflattering mirror, reflecting our own hidden societal biases right back at us. Take what happened back in 2015. A developer named Jackie Alsine opens up Google Photos, and he sees that its new AI has automatically sorted his pictures. And then he sees it, an album, with a selfie of him and his friend, who are both black. And the label the AI gave that album was Gorillaz. Just absolutely horrifying. Now, what's crucial here is that this wasn't some malicious programmer telling the AI to be racist. The problem was the data it learned from. You can think of it as a modern digital version of the Shirley card from old-school photography. For decades, photo labs calibrated all their color printers to one single reference photo of a white woman named Shirley. The result? Well, photos of people with darker skin often look terrible because the system was literally never taught how to see them properly. The training data itself was biased from the get-go. The real-world consequences of this are frankly staggering. A landmark study in 2018 by Joy Buolamwini and Timnit Gebru put commercial facial recognition systems to the test. What they found was just, wow. For light-skinned men, the error rate was less than 0.5%. But for dark-skinned women, it was nearly 35%. That's not just a little bit worse, that's over 100 times higher. The systems weren't seeing everyone equally because they hadn't learned from everyone equally. And this leads us to an even thornier, deeper problem. What happens when the very idea of fairness itself has multiple competing definitions? Definitions that are actually mathematically opposed to one another. This whole question just exploded into the public consciousness with an algorithm called COMPAS. This is a risk assessment tool that's been used in the U.S. justice system to predict if a defendant is likely to commit another crime. The investigative news outlet ProPublica decided to really dig in and asked the question, is this tool actually fair? The company that made COMPAS, Northpoint, defended it. They said, look, our overall accuracy is about the same for both black and white defendants, around 61%. It's fair. But ProPublica looked closer and found something really troubling. It wasn't about the overall accuracy, it was about the types of mistakes the algorithm was making. They found that black defendants who did not go on to reoffend were still twice as likely to be wrongly labeled high risk compared to their white counterparts. So, which is it? Is a fair system one that has the same overall accuracy for everyone? Or is a fair system one that makes the same kinds of mistakes for everyone? Because here's the thing, you can't have both. And this is where it gets truly wild. It's not just that it's hard to reconcile these definitions. Computer scientists have actually proven that it is mathematically impossible to satisfy all the common definitions of fairness at the same time. You literally can't do it, which means We are forced to choose. We have to decide which type of fairness we value more. And that's not a technical problem. That's a deeply human decision with profound consequences.
Okay, so if we can't write down a perfect list of rules, if that's impossible, how can we ever hope to teach an AI our complex, nuanced values? Well, some researchers are trying a totally different approach. Instead of telling the AI the rules, what if it could learn our intentions just by watching us?
This is the big idea behind a technique called inverse reinforcement learning, or IRL. It completely flips the problem on its head. So instead of giving an AI a goal, like get more points, you just show it an expert's behavior, say a human flying a helicopter. The AI then works backward to figure out, okay, what hidden goal could possibly explain that behavior? It's not just copying. It's inferring the intent behind the actions.
And this has led to some pretty incredible results. In one famous experiment, researchers had an expert pilot fly a remote-controlled helicopter, performing all these difficult aerobatic maneuvers. Now, the pilot was great, but he was still human. His moves weren't perfect. But the AI wasn't just copying his shaky hands. It watched those imperfect attempts, and it inferred the pilot's true intention, the perfect, flawless version of the stunt he was trying to do. And then the AI helicopter went and did it, flawlessly, far better than the human could ever hope to.
Which leads us to a final, really profound idea. Maybe the secret to building safe, aligned AI isn't about making it perfectly sure of our goals, but about making it fundamentally unsure.
Let me tell you a story about the number 5. It's a tense night in 1983, deep in the Cold War. A Soviet early warning system detects 5 inbound nuclear missiles coming from the United States. Protocol was crystal clear: launch an immediate, world-ending counterattack.
But the duty officer, a man named Stanislav Petrov, hesitated. He had a gut feeling. He thought, a real first strike, it wouldn't be just 5 missiles. It would be hundreds. He gambled that his perfect, certain, high-tech system was wrong. He reported it as a false alarm, disobeying orders, risking everything. And he was right. It was a computer error. His uncertainty, his ability to just consider that the system might be mistaken, saved the world.
And this is the critical lesson for AI. A system that is 100% certain of its goal is like that point-hoarding boat. It'll pursue that goal relentlessly, no matter how catastrophic the outcome. But a system that's built with a little fundamental uncertainty about our true objective, that's a system that will be cautious. It'll ask for clarification. It'll let itself be corrected, or even switched off because it knows deep down that it might just be wrong.
So, the ultimate danger here probably isn't artificial malice, it's misguided competence. The real risk is that we build a world run by these simple, tidy models of our messy, complicated values, and then we let those oversimplified models take charge, leaving our true, complex humanity in the dust. The challenge isn't just to make AI smart, it's to make it wise enough to know what it doesn't know.